we have a network like this where there's a ladder of resistances and this goes to infinity. And we have to find out what is the equivalent resistance between A and B. That is, we have to find what is the equivalent resistance between A and B. So this we have to find out. Whenever we have questions like this of kind of an infinite arrangement of resistances, over there the first approach is look for the repeating units. That is number one. And second thing to understand is infinity plus 1 is infinity, infinity minus something, that is also infinity. Now what do we mean by these things when we say look out for a repeating unit and infinity plus something is infinity and infinity minus something, that is also infinity? So over here we see the repeating unit is, this is a repeating unit, this is R, this is 2R and this is 3R. So this is one repeating unit. Once this repeating unit is identified, then what we say is, let's say between A and B, equivalent resistances are equivalent between A and B, right? So if this is R equivalent, then certainly if I take this point as X and I take this point as Y, and if we redraw it, so it is going to be something like this. This is R, this is 2R, this is 3R, over here is X, over here is Y, and once again this unit repeats. Same way R, 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 this is 2R, 2R, 3R, 3R and so on. Obviously this is identical to this. So now what we have done is we have just removed one unit from this, and whatsoever is the equivalent resistance between X and Y, this is going till infinity. So whatsoever is the equivalent resistance between X and Y, the same will be resistance between A and B. And if we call this resistance as R equivalent between X and Y, that is R, X and Y, we say it is R equivalent. Then certainly between R, A, B, that is also R equivalent. Between X and Y, if we say this, it has a R equivalent. So between A and B also R equivalent only. So now what we can do is, we can remove this from X and Y, we can remove this whole thing. And over here, instead of this, we put it as R equivalent. Now what we see over here, this and this, that is parallel, this and this is parallel, then this plus this, they are in series, and that should also make it as R equivalent only. Now this and this is parallel, so this makes an arrangement like this is R, equivalent of this and this, let's call it as R double dash, and this is 3R. Between A and B, we have said that is it is R equivalent only between this and this. So this and this, they are series. So let's first find R double dash. This and this, they are parallel. So these calculations, they have already been done. To save time, 1 by R double dash is equal to 1 by 2R plus 1 by R equivalent. 1 by 2R plus 1 by R equivalent. When you solve it, this comes out to be like this. Now this plus this, they are in series and they make equivalent resistance as R equivalent only. So R equivalent is R plus R dash plus 3R. This goes like this, you solve it. This comes a quadratic equation in R equivalent. You can easily correlate to a quadratic equation is X. It is something like X square minus 4RX minus 8R square. So if we have standard form of quadratic equation as AX square plus BX plus C is equal to 0, over there X is equal to minus B plus minus root of B square minus 4AC upon 2A. And over here we know that is A is going to 1, B is going to minus 4R, C is going to be minus 8R square. So when we solve this, we are going to have two values of R equivalent. One is positive, the other is negative. So obviously R equivalent cannot be negative. So R equivalent comes out with 2R, 1 plus root 3 ohms. That is the answer. So whenever you have questions like this of an arrangement of resistances till infinity, you always look out for a repeating unit. It is not necessary that repeating unit will be just of these things only. This could be even a slightly more complex also. Let's say over here, this is R1, R2, this is R3, this is R4, this is R5, and let's say this is R6. This could also be repeating. Once again, the same unit could be repeating over here also. So then this becomes a repeating unit, this becomes R equivalent. So this, and now you solve it, and between A and B, once again you put it as equal to R equivalent. You solve it, this and this that is parallel, then this that is in series, then this and this is parallel, then this and this that is in series, and that makes equal to R equivalent only. You will get some equation, you can solve it to get the value of R equivalent. So whatsoever is the combination like, the first thing is look out for the repeating unit, then infinity plus 1 or infinity minus 1, that is also going to remain as infinity only. So after that, the resistance, they are just in series and parallel. You can solve it for the R equivalent. You may get a quadratic equation. You can solve this quadratic equation. You can neglect the extraneous roots, that is the resistances which come out to be negative. You can neglect them and you can accept the answer which is in positive terms.